Alright everyone, today we're going to practice our integration techniques. So just here's a couple practice problems. There's 1, 2, and 3. And we're going to just go over these types of problems. So let's start off with this one. Here you're definitely going to have to do u-substitution. So we're going to define u as 1 plus cosine x. And that means du, the derivative of u, would be negative sine of x. But let's bring the negative over. So there'd be negative du equals sine of x. So now, look, going back to our original problem, we can just substitute u, and we would get the integral, the negative integral because it's negative du, of 1 over u squared du. Now you can use basic integration techniques to solve. So the derivative or antiderivative of 1 over u squared would be just ln of u, absolute value of u, squared. Seeing how the negative's there, negative, and that would be it. But we have to include the constant, so plus c. Now that you have what u is, now let's bring everything back. So just plug u in here, and we get our answer as, let's see, it'd be negative inverse secant ln of 1 plus cosine x. And yes, so it would still be a plus c because this is not a definite integral. And I believe that is our answer. Sweet. Okay, we'll move on to the next one. Let's see here. E to the x, or e times e to the x. So let's just do u substitution once more, but this is a different kind. It's not just basic u sub. It's integration by parts, I guess. And this would be dx. Actually, it's not parts. It's like, we call it ultraviolet voodoo. I'll explain why in a minute. But you have to have two separate variables, and these would be those, because derivative e to the x, e to the x. Okay, so we just based off lipit, which I'll explain what that is right now. I'm backing up now. So L stands for logs, or ln, I stands for inverse trig, P stands for polynomial, E stands for exponents, and T stands for trig. So based on this, you figure out what you define u as. And seeing how u is x, that'd be under the polynomials, I guess, is where it'd fall into the category. There are no logs, there are no inverse trigs. There's polynomial, which is technically considered the x right there, and then exponents, or e here, but that's next, so that's why it goes here, and then inverse trig, and we don't have any of that. So that's just how you pick your u sub, or how you pick your variables. And then ultraviolet voodoo, where does that come from? Well, you're gonna do x e to the x minus voodoo, which is just e to the x dx. So where the heck did that come from? Well, u, v, so ultraviolet, and then v again, do, so voodoo. So that's just how you do. So here's u, here's v, and then minus the integral of voo, which is v, and then do dx. So that's how you do that setup. Then we're going to keep going, and pretty much you know the derivative of e to the x is e to the x, or antiderivative. So you would still just get this, and then plus c, and that's pretty much that. Alright, last one's pretty, well, I guess it's just interesting problem. It seems like it'd be repetitive and go on forever, but let's just see where things go here. So let's do, again, ultraviolet voodoo, so integration. So, let's see. So we'd get this for our setup, and same thing following Lipit. Just split it up like that. So just go use ultraviolet. So here's ultra, and here's violet. And then, since it's subtracting a negative, it'd be positive. Here, the integral of e to the x cosine x dx, and you're like, uh-oh, how do I take the integral? That looks almost like the same problem. So, well, guess what? You're going to have to do this once again. So this will be the setup for this part of the equation. So again, u is e to the x, and then du is e to the x dx, because the derivative and antiderivatives are the same. Dv would be cosine x, because that's how these two are correlated. And then the antiderivative of cosine x would be sine of x. So then you evaluate this again. So let's just keep in mind that this is only this half of the problem. I guess everything over there. So we would get, let's see, e to the x, oops, make it neater, e to the x sine x minus the integral of e to the x sine x dx. Sine. Oop. There we go. And then you're like, wait a minute. We're repeating again. This is actually the exact same integration problem as our question. So that's actually a good thing to point out. So let's real quick bring this down here. So remember, we still have everything over here, which is negative e to the x cosine x. So now we have this, and we're like, okay, now what? Well, all this equals our original problem, so I'm just going to put like a line here, question, I guess. So what's that mean? Well, you would add this over here, and you would have two of these, right? So it would be 2, and then the integral of blah blah blah. I'm out of space, but it's basically 2 of these. So it's just like saying I have negative x here equals x, and then blah 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 blah. If you add x to both sides, you get 2x. So that's basically saying 2 times the integral. So then all you would have to do at the end is divide by 2 to both sides, except this is now over there. I know I'm kind of lazy. I'm really sorry, guys. And then your final answer would be that. And remember, always include the plus c's. Well, only include the plus c because we don't have any limits of integration here. It's just basic antiderivative. And this is just a technique to solve it, so that's the answer. I hope this is understood. Yeah, alright, see you guys.